Welcome to the Knowledge Catalog. This is physics. This is what we're going to feature as a learning competency in this video. It is to determine the number of protons, neutrons, and electrons in a particular atom. If you are a teacher or a student in the Philippines, that means a teacher in science in the Philippines, you may actually use this the presentation used in this video. For your own instruction, I can give you a copy. Just message me through my Facebook page. It is on facebook.com/knowledge catalog/. Okay, so this is another topic, and I hope that you are going to stay with me until the very end. Ayan, so let's begin. So it is specifically for advanced physical science, and it's going to talk about the physics of the atom. The topics that are listed underneath are the topics we're going to talk about in this video. So yeah, let's begin with the first one, which is the usual understanding of atom that we had, at least during the time of Joseph John Thomson, who proposed the plum pudding model, which is a model of the atom in which the soup of positive charge has embedded in it electrons, just like raisins are embedded on bread, and thus making it also known as the raisin bread model or the plum pudding model. And so, however, there was a time when, syempre, models are really important when it comes to representing knowledge, because they tend to represent as well something that may not be understandable, because readily understandable, because that something is happening at such a molecular level. So, the model of the atom is one of those models na kailangan may improve. And during the time of Ernst Rutherford and his team, they found out that if we are going to just follow or accept the plum pudding model as the generally accepted model, it will not actually stand because of the presence of some a lot of undeflected alpha beam particles during the conduct of the alpha scattering experiment. The alpha scattering experiment the alpha scattering experiment used, alpha beams that are actually composed of helium nuclei, which were positively charged. In this case, yung mga positively charged particles are expected to be bent or to be deflected back to the source, or to just pass through upon hitting different areas in the gold foil that may not be or may be close to a positive charge. So, since the plum pudding model is bragging about a soup of positive charge, dapat, there has to be a minimal amount of undeflected particles. Again, if it is true that the atom is composed of a soup of positive charge, then kailangan konti lang yung mga particles na undeflected. But during the alpha scattering experiment, that was not the case, and it seemed like the positive charge is just concentrated in a particular region, and then the regions that are near the that particular region seem to just let the alpha beams pass through. And so this observation also led to Rutherford's discovery of the nuclear model of the atom. And so yung from plum pudding model naging nuclear model. So we mentioned Joseph John Thomson and Ernst Rutherford in talking about the history so far of the atomic model. Now, because of the discovery as well of the nucleus na meron nga siyang, later on we found out that the nucleus is comprised of not just the positively charged particle proton, but also of the neutrally charged particle neutron. We also came up with this new understanding of the atom not as an indivisible, an indestructible particle, but as a particle indeed that you can divide into its component subatomic particles. And the three subatomic particles that we still hold true up until today are the following. So proton is positively charged, neutron with 0, and electron with -1. Their relative mass in atomic mass unit are the following. So as we notice, napaka-negligible ng atomic mass ng electron. So, usually, hindi talaga siya sinasama sa solving. So, yung lang proton and neutron yung usually binibilang. And their symbols are also shown in this table. In addition to this, the number of protons in the nucleus of an atom indicates the atomic numbers, the identity of a particular atom. So, any atom that has 6 protons in it is always a carbon, and then an atom with 95 protons will always be americium. And in most cases, in science, nucleus is a term that is not just used here in chemistry or in physics. We also find the term nucleus in biology, and usually it refers to a very important part of anything. Okay, in the case of the cell, it contains the blueprint with which everything else must be compliant to. In the case of the atom, we will further be understanding the importance of the nucleus when we discuss isotopes, nucleons, and nuclear processes. So just bear with me. For the following sample problems, simple lang naman ang tinatanong dito. So, ilan ng protons na makikita sa atom ng argon? So, remember, ang format natin dyan is X, represented by, argon, represented by X, tapos A, yung superscript, which is 40, in this case, that's 40, and Z, which is 18, subscript, okay, which is, yun nga, as shown. The givens for this problem are the following. Yung atomic mass is 40 grams per mole and the atomic number is 18. Again, if you want to have a copy of or if you want to know where we got this information, you will find it sa mga periodic tables natin. Yung unknown natin is yung number of protons, and we can use the following formula. The formula states that the atomic number must be equal to the number of electrons, and it must also be equal to the number of protons, since, an atom is supposed to be electrically neutral. So the following solution will hold true because atomic number is 18, the number of electrons must also be 18, and the number of protons is going to be 18. For sample problem number 2, we are supposed to look for neutrons that are found in bismuth 209-83. So remember, 209 is the atomic mass and 83 is the atomic number. Where did we get the information? We got it from the periodic table. So the unknowns are the number of protons and the number of neutrons. So how do we figure that out? Yung formula na gagamitin natin is that yung kaninang formula and then a new one, which is atomic mass is equal to the number of protons and the number of neutrons. Now, question. Bakit yung formula for atomic mass, yun lang number of protons and neutrons, ba't wala yung electron? Pwede rin idagdag dyan ng electron kaso, since yung mass ng electron is too small, it is almost negligible. So, carry lang, okay lang, kahit hindi mo na siya i-include dyan. So for the solution, we have the following. We first look for the number of protons, which will be equal to the atomic number, 83. And for the number of neutrons, we are going to just substitute the following givens. We got the mass, which is 209. We have the number of protons, which is 83. Now we are just looking for neutrons. Now we are going to subtract 83 from both sides of the equation. And then what we'll be getting is only 126, which also is our answer. For one of the two answers we're looking for in this problem. Ayan. So, sample problem number 2 is just like that. We are not doing transposition here. So, ang term na gusto kong gawin is do an operation on both sides of the equation. Okay? And so, an isotope is, it may be 2 or more species of an atom of the same chemical element that has the same number of protons. So, pareho lang yung atomic number niya. And yung placement niya sa periodic table, which means same place, so isotopos. Kaso, yung atomic masses nila is magkaiba. Now, question. Di ba ang atomic mass is the combination of proton and neutrons? Since hindi naman daw nagpapalit yung number of protons ng mga isotopes for a particular element, anong nagpalit ngayon? You guessed it right. It's the number of neutrons. Yun yung nagpalit. So the importance of identifying these isotopes lies with the observation that all atoms of the same atomic number, that is the same element, may have nearly, if not precisely, the same chemical behaviors. Thus, a collection of isotopes constitutes a sample of an element and not just one. So for the isotopes of 11, of hydrogen, ito yung point nun. Ito yung ibig sabihin ng paragraph na yan. Okay, so ang isotope ng hydrogen, meron siyang H11, das H21, and H31. Ngayon, ang hydrogen, hindi siya isa sa tatlong yan. Hydrogen that is found, yung information na nakikita natin sa periodic table, yung hydrogen na dinidescribe ng periodic table is not just one element, it is actually these three elements. Ang nangyayari lang is meron ng hydrogen, form ng hydrogen na mas common sa nature kumpara sa iba. Pero for us to get the identity of hydrogen as we know it from the periodic table, we need these three isotopes of hydrogen. Okay, these three isotopes of hydrogen, they all are hydrogens because they only have one proton in their nucleus, but they are not the same hydrogen kasi meron silang iba-ibang number of neutrons. Now, in naming them, remember that we are going to use the following format. So, symbol A and Z. A is for atomic mass, and then Z is for atomic number. Now, some authors do not really prefer using these scripts. They may write the whole element name with its atomic mass, tapos it is in this case. So, hydrogen 1, hydrogen 2, hydrogen 3. In case na ayaw nila yung shorthand. Now, questions. If nucleons are subatomic particles comprising the nucleus, now, alin yung mga nucleons? Okay? Sa tatlong subatomic particles, alin ba sa mga yon yung makikita sa nucleus? Okay, that will be the protons and neutrons. Now, since they are much heavier than electrons, do they comprise much of the atomic mass? Of course, the answer is yes. Now, do they dictate the identity of the atom? Okay, remember, saan nakarely ang identity ng atom? Nasa protons. Now, can the number of electrons dictate the identity of an atom? Remember, ang mga electrons pwede silang mapasa, pwede silang ma-share. So, no. Since they change their locations, they can be transferred, especially if it's an ionic bond, merong electron giver, merong electron receiver, or yung donor nga, ganun, saka receiver. Hindi siya pwedeng gamitin as the an indicator of identities ng isang atom. And so, only the protons. Also, yung neutrons di rin pwede kasi it also changes. Remember, an isotope, isotopes, they do have the same number of protons, but they don't have the same number of neutrons. Now, if that is so, can the nucleus adjust or change to change the identity of the atom? Kaya bang, kung gustong magpalit ng identity ng atom, kaya ba niyang gawin yon? At paano? Sa tingin niyo? Okay. Kaya, it has to happen though through nuclear processes. Now, to proceed, kailangan nating magkaroon pa ng basic understanding ng nucleons and isotopes. So, let's proceed. So, sample problem number 3. Ang isang isotope has a mass number of 11. Tapos yung number of neutrons niya is 6. So, determine naman the atomic number and name of the isotope. So, yung givens natin are the atomic mass and then the number of neutrons. So, neutrons given, pero di talaga siya pwedeng gamitin as an indicator of, an indicator of the identity. Again, remember, it's only the proton. Unknown natin is yung Z, which is the atomic number. Kasi pag nakuha natin yung atomic number, it is going to tell us kung aling electron ang kinakausap natin. Aling atom ang kinakausap natin. And then the name of isotope. So, the formula is going to be atomic mass is equal to the number of protons and the number of neutrons. So, the following is our solution. Just substitute the givens. Ang unknown natin is the number of protons, and you will be getting 11 minus 11 minus 6. So, you'll be getting both sides of the equation. So, what you'll get is 5. Yung atom na hinanap natin yan is 5, element 5. So, it's boron. And the isotope name for this is going to be boron 11. Okay, I hope you're following. Okay, so yeah, let's proceed. Nuclear reaction. Ang nuclear reaction, ang pinakasimpleng konsepto nila is that they change the nucleus of an atom into a different form. So, may binabago sila sa atom, and it's going to be the nucleus. Since bago na yung nucleus, it's going to also have a new identity. Now, similar to the chemical reactions where compounds may turn into new compounds by swapping their electrons, nuclear reactions happen when the number of protons or neutrons, collectively referred to as nucleons, change. So remember, when we refer to nucleons, we are putting together protons and neutrons since they are the subatomic particles comprising the nucleus. Now, the changes are made possible by kicking out of protons from the nucleus of an atom or by converting it into a neutron. Either way, changing the number of protons in the nucleus. Now, all types of nuclear processes also shoot out some particles such as photons or electrons as a side effect. The shooting of photons or electrons are not actually the major product of these processes, but they are only byproducts. Okay, so these particles can act as tiny bullets. They can be as harmful as, penetrating the flesh. And so, yeah, this idea is very similar to the concept of alchemy, actually, because ang alchemy is all about changing lead to gold, changing a particular element into something new that is preferably more beneficial or, expensive. Okay. But this is extremely random, and it is as the exact time it would take for such reaction to take place can be anywhere between a second or many years. So, even though it is similar to alchemy, the process is still, even despite the many technologies na meron tayo ngayon, this is still not something that we would be able to shorten because it usually takes a lot of years, okay, for nuclear reactions to happen. Now, most nuclear reactions are not harmful, okay, but they are actually harnessed for medical or some diagnostic purposes. So, yun, ang changes na nangyayari sa nuclear numbers of an atom affects nuclear processes. But what about isotopes? Paano nila naapektuhan yung nuclear process, or how are they involved in the nuclear process? Okay, so let's take the following example. So, neutrons and protons roughly have the same mass. So, carbon-12 is more common and stable compared to heavier isotope of carbon-14, which has 6 protons and 8 neutrons. So, it is nevertheless observable in nature. If you were to count carbon isotopes, you will rarely find carbon-14. But since both isotopes constitute a sample of carbon, they would affect, both of them, the atomic mass of the element as it is reported in the periodic table. Now, carbon-12 is more common than carbon-14, pero yung carbon-14 has a bigger value for atomic mass. It therefore skews, so ibig sabihin sa statistics, parang in-incline niya, yung atomic mass of carbon to a value relatively higher than 12, as in this case is going to be 12.011. Now, ano ibig sabihin nun? Since mas stable ang carbon-12, hindi madali para sa kanya mag-undergo ng nuclear processes. But carbon-14, it's easier for carbon-14 to turn into nitrogen. Ayan. So, let us have another sample problem. Remember the following. Average atomic mass is equal to the percentage of abundance tapos yung isotopic mass. So, yung percentage of abundance is usually given, such as in this problem. Tapos yung isotopic mass is also going to be given, such as in this problem. And then you're going to multiply them, tapos you get the sum, and you'll get the average atomic mass. So in this case, in this problem, we're asked to solve for the average atomic mass of carbon by just using carbon-12, which is 98.89% abundant, and it has 12.0000 isotopic mass, and then carbon-13, which is only 1.11% in abundance, and it has that isotopic mass. So those are our givens, and then our unknown is the average atomic mass of carbon. So how do we do it? And this one's the formula. So simply just multiply 0.9889 Since that is the percentage, kailangan mo lang siya talagang i-move ng dalawang decimal places to the left. And then multiply it with the mass of carbon-12, which is 12.0000. So do the same for for carbon-13, and then get their sum. You will be getting 12.011, which is something you will see on the periodic table. So again, let me reiterate that a particular element given in the periodic table is not just one element. It can be a combination of different elements, and those elements are just actually isotopes for that same element. Now we have the same kind of problem. We have a calculation for the average atomic mass for bromine. So the following are our givens, the following are our unknowns. You may pause this video to try and figure this out by yourself. This is still our formula. Now that you have decided to continue the video, okay, so let's deal with the solution. So simply the same, just multiply them, get the sum, and then you'll get 79.9057. Now the types of nuclear reactions. So a nucleus breaks into two parts. So the first part is a chunk. In this case, it's right here. So it's with 2 protons paired with 2 neutrons and a total of 4 particles in a single chunk. So this is actually a helium particle with 2 protons, and it's also known as an alpha particle. So for alpha decay, which is the first type of nuclear reaction, ito yung nagre-radiate. Okay, and then the another piece, which is this one, okay, it constitutes the original nucleus minus the alpha particle chunk. So the radiating material is the alpha particle. So say for instance for alpha decay, kapag nag-decay yung radium, it will become, through alpha decay, ang mangyayari sa kanya, it will become a radon, and it has helium 2+. So ibig sabihin nito is alpha particle. Remember that alpha particles are made of helium. Now, the radium, as it was said here, it has an atomic number of 88. It decays into an alpha particle by losing 2 protons and 2 neutrons, deliberately decreasing the atomic number by 2, producing an element with an atomic number of 86, which is, yun nga, radon. So say for instance, uranium-233 and its atomic number is 92. Say it undergoes alpha decay. It identified the resulting isotopes nuclear notation. So by saying nuclear notation, ano kaya yung bagong element and yung bagong atomic mass na pinag-uusapan natin. So yeah, the givens are the followings: the atomic mass and the atomic number, and then the unknown is the resulting isotopic nuclear notation. Our formula is going to be as follows. So notice na nandyan na si uranium, and nandyan na rin nakalagay si alpha particle, which is again 4, 2 helium, and then ang hanapin lang natin is yung nasa para dun sa blank. So yeah, since 233 is going to decrease by 2, by 4 yung mass niya. So what now is going to be the new what is going to be the new element? It's going to be 220 with 229 and 92, and it's going to be thorium. Again, it's going to be thorium. Now, what is wrong about this answer? Okay, so dapat 229 yung 229 yung resulting na difference, because 233 minus 4 is going to be 229, and then 92 minus 2 is going to be 90. So thorium 90. Next is platinum. So platinum has 175 atomic mass and then atomic number of 78. Now, what is going to be the resulting isotopic nuclear notation? Okay, we'll be using the following sentence. Okay, so the answer is going to be osmium 171 and 76. So 175 minus 4 is going to be 171, and 78 minus 2 is going to be 76, and 76 is the atomic number for osmium. So from platinum, naging osmium because of alpha decay. Now, the next type of nuclear reaction is beta decay. So it has first types. The first type is when one neutron in the nucleus suddenly changes into a proton, increasing the atomic number and thus changing the element, and triggering a positive charge which will be immediately counteracted by the creation and release of an extra electron from the nucleus. In this case, the radiating particle is an electron, yung nag-try na i-even out yung isang bagong proton. Okay, so the second type is when a proton becomes a neutron. So from a positive charge to a neutral charge. It thus decreases the atomic number, making the atom negative, which triggers the creation and release of positrons, which are acting like electrons but they have a positive charge. In this case, the radiating particles are positrons. The first type is going to, the neutrons changing to the two protons. So, magiging one step higher yung atomic number. So, +1 mo yung atomic number, yung next na element nun, yun yung magiging bagong element natin. Pero, with the second type, pabaliktad naman siya. So, yung proton magiging neutron. So, one step backwards naman siya. So, halimbawa, si element na ganito has the following atomic number. Since bawas na siya ng isa, mag-backstep siya ng isa. Now, in both cases, merong pwedeng maging siyang negatively charged particle or pwede rin siya maging positively charged particle. So, ang nangyayari lang dyan is in the first case, an electron was produced to even it out, and then for the second case, a positron was produced. It behaves like an electron kasi it's not like as heavy as an actual proton, pero it has the positive charge of a proton. So yeah, that's a positron. A beta decay that radiates electrons is what you call as a beta minus decay. So kapag yung niradiate is an electron, such as in the first case is called the beta minus decay. And then yung pangalawa naman, it is beta plus decay because it radiated positron. Yan. In this case, ito rin, for example, potassium, which is atomic number 19, it turns a neutron into a proton, so it is one step higher. Increasing the atomic number, it will become 20, which is calcium 20. And calcium, which has the atomic number of 20. Now, this process creates and releases an electron and a V particle, which is an anti-neutrino. Yun. So, sample problem, we have technetium-99, atomic number of 43. It undergoes beta decay. So, the following are the givens, atomic mass and number. The following is the unknown, and then the following is our sentence. So, technetium is going to turn into ruthenium. One step higher since it's beta decay. So, one step higher siya. And in this case, from technetium naging ruthenium. So, notice that it has the same atomic mass, pero they don't have the same atomic number kasi nga nagbago na rin yung element. Next is for sample problem number 9. We have the following mass and the number, and then we have the following unknowns and the sentence. So yeah, bromine is 8235, so through beta decay, it will become krypton, which has an atomic number of 36. The last type of nuclear reaction to be discussed in this video is going to be gamma decay. So during this type of nuclear reaction, the nucleus releases radiation without actually changing its composition. Ang nangyari lang dito is kung halimbawa merong element na may 12 na protons, 12 na neutrons, ganun pa rin naman after gamma decay. Okay, so ang concern kasi dito is not really the number of each of these subatomic particles. Ang concern niya dito is yung arrangement ng mga nucleons sa nucleus. Yung pagkaka-arrange ng proton at saka ng neutron sa nucleus, yun yung pinaka-major na concern dito. Okay, so when electrons get rearranged kasi from a high energy level to a lower energy level, they emit a high energy photon, which are called gamma rays. So the same happens when nucleons rearrange themselves from a high energy state to a lower energy state. So let's have the following examples. Expect that thallium-202 is going to have the same atomic number and the same atomic mass. Okay, ang nangyari lang talaga is meron lang na-release na gamma rays. So in this case, notice it. Okay, so yung 202 in our givens is also the same 202 in the products, and then the 81 and the thallium, yun yung symbol niya, pareho pa rin siya, walang nagbago, same ang element. Okay, and nangyari lang is na-rearrange lang talaga yung protons at saka yung neutrons. Okay, so concern ba natin dito yung electrons? Not really. Okay, kahit na anong rearrangement ang mangyari sa electrons, it's not going to undergo gamma decay. Next is iodine. So iodine is 125 mass and then 53 number. Expect that it's also the same, 125 and 53 sa products. Okay, nag-rearrange lang. Then again, yung protons and neutrons that you find in the nucleus, which is, reason why we call them nucleons. This is our topic for advanced physical science, the physics of the atom, and I hope that this video has helped you in understanding it even just a bit. Okay, so the Knowledge Catalog is a brand being developed by a teacher creator. Yours truly. It is quite late from my end. It's 12:57 a.m. I am a high school teacher in the Philippines, and I love developing content I find useful and needed to better my instruction. If you want to support my channel, kindly subscribe to it. And if you want to like this video, then please do so and leave a positive comment. And please, if you want to be notified whenever I upload new things, just hit the bell button. See you in the next video.